Okay, good morning. The fourth unit is related with ARM processor. Actually, it is content related with the parameter of risk and ARM processor fundamental. So the half section which consists of risk design philosophy, ARM design philosophy, embedded system hardware, or some bus protocol is mostly related with AMBA and bus ARM bus technology and some memory peripherals, embedded system softwares, and initialization. Uh, that is a booting code related with that one. And second half is concerned with ARM processor fundamental, ARM core data flow models, then register, current programming status registers, pipeline, execution, and interrupt of vector tables and core. So this parameter will mostly concerned with the ARM process. That is the fourth unit of your embedded system related with parameter. So considering this parameter, so before we start, we go with the actually ARM core data flow model. What is the meaning and how the data flow in a ARM processor related with the parameter. So considering this diagram, just go with that. So whatever the data actually will be available, first it uh, fetch by a instruction decoder. So whatever the instruction we have to need to be executed, first it need to be a decoder or decode that instruction, or we say that fetch that instruction. So we can take the action, or the processor will be a take the action depend upon that instruction. After that, it goes to the sign extended. In signed extension is connected with a register file which having a total 15, there is 16 register, that is R0 to R15. So whatever the data will be required for the respective instruction, that data will be collected from this register, that is R0 to R15. After that, collecting the data respective of instruction, just we take like suppose we do with the arithmetic and logical unit at addition of two number, suppose A and B number. So first instruction is decoded related with the addition of two number, and so the data of related with value of A and B will be collected from the register file. After that collection of data, the instruction is goes to the ALU or barrel shifter, or sometime we say that the MAC, depend upon the related operation. So after collecting data from register, the instruction goes to the ALU. ALU will be execute their operations is like A plus B. And after whatever the result coming from either the ALU or MAC, that will be again stored into a register for the updatation process, whatever the data. So suppose we store it value in a C. So the C value will be incremented because of new addition, and it is again write to a even in your memory. That is a write. So we say that the register again update the result through the write command in a data. So this way the process will be executed. So after that one, this instruction is goes to the address register. So address register will be a do that respective task and assign the task, and it is goes to the addresses. So after execution first task, it will be incremented by one. So increment, or we say that program counter will be given here to count the execution of number of programs and number of tasks. So it will be incremented. So we can understand that the execution of respective tasks. So in this way, the ARM core data flow model will be executed. So go with the theory. So ARM core data flow model illustrate the how a fundamental unit are interconnected by the data buses, showing the flow of data within the ARM and architecture. So consider this. First is a functional unit. So the ARM core consists of various functional unit, including the arithmetic logical unit, that is addition and logical operation and or XOR, that one. Then multiply accumulator, that is MAC unit, and barrier shifter, that will be a go with a shifting of bits. So we know that the division, that operation will be executed with a shifting operation. Then ALU and MAC retrieve the value from the data path and store a result back into a register file, which is a collection of general purpose register used for the temporary storage. We know that after the operation of completion of ALU and MAC, it is stored back to the register. So for the update, the value of whatever the operation will be conducted, right? So that will be done. So considering with register, actually there are R0 to R15 register. Uh, Considering that parameter R0 to R12 are general purpose register, R3 are the stack pointer, R14 are the link register, and R15 is the program counter. For by the specification of division of that register that will be mentioned. Then A and B bus, they are used for the data from register flow through the two path, that is A and B. Whatever the data flow from the register to the respective unit, either arithmetic logic unit or barrel shifter or Mac. That is go with these two buses, A and B. That is we say that data buses, which is coming from register file to the respective unit. So that parameter will be considered in A bus and B bus. Then barrel shifter, it performs the shift left and right and rotate operation of the data bits for the respective execution operation. Then arithmetical logic, which perform arithmetic and logical operations. Then Mac, multiplying the accumulated unit, specify unit for the multiplication. Address register, hold the memory addresses for load and store the program. After that, we go with the incremental. That is automatically increment the addresses or program counter for the execution of next program and next task and whatever the parameter. It helps in sequential instruction execution. So this is related with how a data flow within the ARM processor, right? So that is the advanced um, reduced instruction set mechanism, which can be a help how the data flow from the basic point of view from the start of to the end, start of the end parameter. So this is concept related with the ARM core data flow model that is related with the parameter concerned with the units. So go with this point. Actually, it is an important point for the exam point of view. So most probably this question will be asked during the examination, right? So this parameter is concerned with that.